The problem I am doing is on Chapter 2 and it involves free fall. The equation for free fall at the surface of Mars is s equals 1.86 t squared with t in seconds. Assume a rock is dropped from the top of a 200-meter cliff. Find the speed of the rock at t equals 1 second. The equation we will be using to solve this problem is the limit as h approaches 0, f of t plus h minus f of t all over h. For this equation, f will be the 1.86 and t will be the t equals 1. And you first start by plugging the numbers into the equation. So f of t plus h would equal 1.86 plus 1 plus h squared, which would equal 1 plus 2h plus h squared. And f of t would equal 1.86 times 1. And if you plug this all into the equation, it would equal the limit as h approaches 0, f or 1.86 times 1 plus 2h plus h squared minus 1.86 all over h. And you multiply all of these, or 1.86 to the 1 plus 2h plus h squared, and that would equal the limit as h approaches 0, 1.86 plus 3.72h plus 1.86 h squared minus 1.86 all over h. And the 1.86's would cancel out, and you would be left with limit as h approaches 0, 3.72h plus 1.86h squared all over h. And because each of these numbers have an h in it, you would cancel out one of the h's, and you'd be left with limit as h approaches 0, take out an h, and you'd be left with 3.72 plus 1.86h all over, or just that. And then you would plug in 0 for all the h's, and you'd have just be left with 3.72, because 1.86 times 0 would be 0, and it would be 3.72 meters per second.